Okay, so let us start. Okay, so in the previous slides, we learned about this is only on the construction working of your diffractometer, and also what are the things you need to take care to get a good quality data. So, if you want to do really good analysis, your data has to be of good quality. If not, it would make no sense for any kind of qualitative analysis. So that is the reason why I explained all these things, and you need to take care of all these things. Then let us go for the next step. So should we? Okay. So when it comes to your uh, X-ray diffractometer, so what you do, you normally give your sample. They would put on a diffractometer, and then they will give you some recordings. So right in now what how it looks like is this is what normally your XRD pattern for any given sample would look like. So this is your X-ray XRD pattern, X-ray diffraction pattern for your NaCl powder. So if you take the simple NaCl powder, so this is how your X-ray diffraction would look like. So what you can see here is there are peaks in some position. You and uh, even these peaks would have different intensity. So this is mainly due to the angle of. This is mainly based on the your diffraction, your Bragg's law. Okay, so in this case, if you see there is 200 is prominent. That means uh, you are having more planes which are oriented in 200. And if you take 111, it is lesser. That means you have less number of planes which are oriented in 111, and it will correspond to a specific Bragg's angle, which is your diffraction angle. So this is normally again in 2 theta. The reason why 2 theta is, so if you go back into this diffractometer, so I told your X-ray is mounted on one of the wheels, and detector is mounted on one more wheel. So when you have movement, both your X-ray and the detector will move in the same direction. Okay, so or with the same speed. So that is why you have theta from theta angle from X-rays and theta angle from detector. So this is what we call as 2 theta geometry or Bragg-Brentano. So this is normally called as Bragg-Brentano geometry, where both your X-rays and detector would move. So there are some X-ray diffractometers. For example, if you take some old tabletop diffractometers, your X-ray tube is fixed. So only what happens is your both the sample and your detector would move. So still that is your 2 theta arrangement. Okay, so sample stage and detector both would move with constant speed. Okay, so or constant angle. So okay, so if someone has some question, you can ask. Someone was raising hand. Okay, so I think I will go into the next one. Okay, so this is why it is in the 2 theta, and in some cases you may you for instance if you are doing a thin film, then you may go for theta only theta. So that is a different arrangement. So we will not go into the detail of that. Okay, so now we will see what is the next step. What you are to supposed to do. So what is the meaning of the line appearing at certain angle? Then why some peaks are less and a few have higher intensity? Okay. So as this is what I told. So this depends on how many number of planes are in the uh, diffraction plane. Okay. So if you have more number of planes in the or more number of atoms in that plane which are diffracting, then you get better intensity. And if you have less atoms in that plane, then you get less intensity. So this is what you have for your intensity. So when it comes to intensity of these peaks also depends on the motifs or the molecules. For example, each atom they have their own scattering and diffraction ability. So if you take lead would normally absorb more than the diffract, okay, or reflect. So in that case, what happens is you have less intensity. That means the intensity of a lead atom would be less compared to your copper atom. Copper atom would give better reflection, or some other atom would give better reflection. So in that case, so this is one of the information that you can get. So this intensity or the height of the peak also depends on not only the diffraction atoms but also the kinds of atom, and also this would be used to do the phase quantification, so that will come to later. And then what about the position is it would give the information of the d spacing. So for example, if you see like as I explained beginning, so the d spacing is the one which actually is the distance between two interplanar crystal planes, okay. So that is given by your theta. So n lambda is 2d sin theta. So if you take n lambda is equal to 2d sin theta, then in that case, your theta would depend on the d, because lambda is constant and diffraction would be almost constant. Okay. So the order of diffraction, n is the order of diffraction, which should be almost constant for a given sample. So normally we take the first order diffraction in most of the X-ray what we do in our labs. So n is equal to 1, and then lambda it depends on the X-ray tube. So if you are using copper, then it is 1.54. If you are using molybdenum, it is 0.7. Okay. So those are the different. Uh, this is almost constant. So next, what you do is you have angle theta. Theta depends on the diffraction, your d spacing. So if I know the theta, so if I know this position of this peak, then I can know the d corresponding d. Or if I know d, then corresponding theta I can know. So those are interconnected. So this is about the d spacing. The position of the peak depends on the d spacing and the symmetry, and also symmetry. So next, what about the width? So someone asks what is the width. So if it is wider, then what does it mean? So the FWHM is normally used to talk about the crystallite sizes. So that we will again come back. And also sometimes it is about the defects, the strain which is in the lattice. So for example, this is lot of this is used in yes, like your metal industry, like your stainless steel industry. So normally if they want to study on the stress, what they do is they take X-ray of the unstrained material. So that is called as micro diffraction. So they have a very narrow X-ray which is falling on a sample. Okay, so for the example, it is falling on this spot, and this is your sample. Then what happens? They take without applying any strain, then what they do, they send the X-rays again. So they take this sample, put some load at this particular point, and then again they do the X-ray diffraction. So in this case, what happens? You can also know the strain which is induced in this lattice. So that is one of the use of this X-ray diffraction. This is normally used in metallurgy. So a lot of if you are working on some metallurgy, or even in iron steel industry, they use this kind of micro diffraction for doing the strain analysis. And then one more thing is, in most of your single crystal, you try to find the crystallite size. So this we will do some exercise on that. So this again I will explain in the next when we come back. Okay. So then peak shape, and again this peak shape depends on a lot of things, because it may be having Gaussian, it may be having Lorentzian, it may be having a mixed your Gaussian and Lorentzian. All these things depends on a lot of things. One is your crystallite size, the strain on your in your sample, So this also shape also depends on something called as your instrumentation. For example, if you are using different slits, your peak shape may change. So this shape also depends on these factors plus instrumentation. Okay, so this is not mentioned here, but you should also take care of the instrumentation. So based on your instrument parameter, you can also have different shape of your for your peaks. So this is these are about your peak shape, peak width, and intensity and position. Okay, so now once you get this data, what you do next? First thing, what are the things you can do is you can do data analysis. There are two broadly two approaches. One is traditional approach, and then there is second one is direct space approach. So traditional approach is normally done on most of your powder diffraction data. Traditional approach is you take your X-ray diffraction data, good quality data. So when I say good quality data, then you have to again take care of it is having good intensity ratio and all those things. So then if you take this data, then what you do is you do pattern decomposition by using Libre method, or you can also do what we call as profile matching. So we are going to learn this profile matching. So profile matching is you take your data and you just try to match it with already known data. Okay, so this is your profile matching. This is your first approach. Next approach is structural solution by modeling. So this is what we call as a ritual. Ritual is nothing but it is a model approach. So this is going to you are going to learn here. Then you can also have some Fourier transform and all those things. So these things we are going to in our in this workshop we are going to do this traditional approach. Okay, because we are going to do more on powder diffractometer or powder diffraction. So we are going to learn more on this traditional approach than the direct space approach. So what is the difference between direct space approach is in direct space approach, your uh, you may not need all this profile matching and all those things. So if you are having a new crystal or new crystal with new structure, then you need to go for this direct space approach. So for this, foolproof may not be the really good tool. Instead, you may go for one more software which is your Jana. So where you can actually do this direct space mapping by using Monte Carlo and simulation or grid search. Okay, so these things you can do. So this is good for single crystal data. May not be really good for powder diffraction. Okay, so on powder diffraction, so we will not touch this part because this is beyond or it needs more expertise in crystallography. So we will try to focus most on the traditional approach. Traditional approach is where you can have some model already known model, and then you can do some kind of structural modeling. Okay, so this we are going to do this all these things in the coming sessions. So now, what is the main thing for traditional approaches? These are the steps. Okay. So first, you take a good data from your diffractometer. You give your sample to your technician or your X-ray in charge. They will collect a good data. Then what you do is you check for quality. Check for quality means you need to check whether it is having good intensity. You need to check whether it is having a good peak. Uh, Splitting or can you really distinguish your peaks, and then all those things you have to take. So that is your good quality data. Then you have to identify the peak position and also the intensity, and then you have to do profile matching and Libre fitting. Okay, so this we are going to learn in detail. So after you do this profile matching and Libre fitting, you can go for structural solution by using your ritual refinement. So when it comes to ritual refinement, you need to have a model. So this model will be used to, this model would contain information about the space group. So which would come from your lever fitting or your profile fitting or your profile matching. So then you will also get you should also have the information about the position of the atomic position, occupancy, anisotropy, and all those things. So this again we'll do in one by one in detail. So this is your traditional approach. Then finally, what you get is you get some crystal structure. How to verify is by seeing the fitting factors and bond distance, bond angles. So these are the verification steps. So this actually contains 5 steps. There is one more step which we will see, which is your profile matching. So this profile matching is almost equivalent to your Libre fitting. So this is having a second one. So we will also learn that part. Okay. So this condition, this entire thing we will learn. So when it comes to direct space approach, so if you don't know the uh, crystal structure of your compound, so that means it is a new compound, new crystal structure. So there is no similar structure which is already existing. Then you need to go for this kind of a direct space approach. Okay. So this is mostly done for organic compounds like your drugs or even some pharmaceutical compounds. So most of the organic compounds, it is better to do direct space approach, and also it is preferred or it is advised just to go for a single crystal data, not the powder crystal data. Powder crystal data would have some disadvantage, which we will discuss. Okay, so that is the reason for direct space approach. It is better always to go for single crystal data, not the powder crystal data. So what is this methodology? Is this has some similar methodology like what we had for traditional approach. Okay. So anyhow, we won't be going into this because this is again very complicated thing. So this itself can be done for maybe 1 week workshop. So this is not in our within our this one. But I will in the end maybe I will show one for any one of the compound. Okay. So if you, so when we do indexing, so after indexing, we I will try to show this direct space approach for a very simple example, maybe like for a cerium oxide or NaCl. So any one of this very simple structure. Okay. So for solving a structure from X-ray powder diffraction data, so this is like a maze uh, game. Okay, so if you are starting here, you are starting with a polycrystalline sample, or maybe your single crystalline sample, where you have taken a powder diffraction data. Okay, so you start with powder diffraction data. Then what are the things you need to do here? Okay, so to arrive at the crystal structure or crystal solution. Okay, so what are the steps? It is like it is a continuous step. So first thing is you take your sample to your lab, your diffraction lab, where you may have lab X-rays with copper or molybdenum or any X-rays. There, or you can do it for synchrotron, or you can do it uh, for neutrons. Okay, so you have any, you can choose any one of the compounds or any one of the radiation. Then you collect the data. So like you need to check the quality for the data. So if it is a very good quality, then what you do is you can go for the next step. Okay. So the first step is you have to do the indexing. So indexing, or you can also have phase matching. So in our case, we will do phase matching. We will also study indexing. So both we will do. We will do indexing by different algorithms, and also we'll do in phase matching to do the indexing. Then we will do the Libre or Pole fit. Okay, so this is your profile fit. We call it as profile fit. Then, so this is almost like you are going through all these things. Okay, then you have to put your uh, data sets. So data sets is nothing but we are going to go here. Okay, so directly we go to the model based data based methods. Like we take space group information, and then we can do that. So or you can also go through this. So there is this is a bypass. So either you can go through this road, or you can bypass here if you know the space group information. Then you can go directly to the structure. Okay. So we are going to use this model-based methods, which is nothing but you take the space group information, we take the atomic positions, occupancies, and all those things, and then we are going to do the structure. Okay, structural analysis. So finally, what you do is you once you put all the things, then you do a fitting, what we call as a ritual fitting. Once you have the ritual fitting, you have arrived at the solution of your compound. Okay, so this is your steps that you need to remember when you want to do a complete analysis of your X-ray diffraction. So this we will come back again, okay, at some point. So now I'll just leave a very small introduction lab.
The arrangement of atoms.
Leave the mic disconnected.
ಪ್ರೆಸೆಂಟೇಷನ್ ಮಾಡ್ತಕ್ಕಂಥದ್ದು ವಾಯ್ಸ್ ಅದು ಆ ವಾಯ್ಸ್ ಕೇಳ್ತಾರೆ ಅದೇ ರೀ ಅದು ವಾಯ್ಸ್
Okay, I think there is some problem with the voice. So, what I will do is I will give this video later so you can see that. So, this is actually uh, just summary of what we learned till now. So, I think so. If you have any questions till now, we can have. Okay. So if you have any questions, you can ask now, or I will go to the next one, which is your. I'll just give introduction for your softwares. Okay. So how to know that obtained data is good quality or not? So this it depends on if you have very good intensity, and also you should have peak separation. You should be able to see the peak separation properly. So if you are able to see the peak suppression properly, then you can actually you can say it is a good quality. At the same time, you should be having very good intensity. So this is what I showed in the previous part. So if I want to say it is a good quality, then you should have good high intensity, better resolution, good signal to noise ratio, and also complete diffraction pattern. So in this case, for example, if I take this example, I should not take data only up to maybe some 5 degree to 40 degree. If I take only from 5 degree to 40 degree, then it is not a good data because I'm losing a lot of information in the higher angle. So that is why it is called as full spectrum. Full spectrum means you should have a maximum number of peaks. So again, it depends on sample and all those things. So I think with this we'll move on because there is some problem with this video. So I will just try to uh, check again if I can get that. Now we will try one more time. So this video is very good. The reason is it is just so it gives a complete it gives the your details. Okay, so I will try to do it again. Okay, I think there is some problem with audio, so it's fine. So we'll go to the next part. We'll come to the integration to your software. So when it comes to software, so even for analyzing all this X-ray diffraction, you have a lot of samples. You have a lot of softwares where it becomes sometimes difficult to choose which one to choose. Okay. So broadly, we can classify this as open source and commercial source. So our commercial software. Open source is the one which is free of cost, like foolproof Jana or GSAS. So very recently in 2012, we have something called as Profex. Okay, so this is very new one. Still, it is under development. Okay, so if you click, I will share this PPT with you. So if you click here, it will go to the official websites. So I have given official website. Then you can see what are the possible things. So in our case, we are going to use full prop because this is more commonly used. You can also use GSAS, but recently they have upgraded to some other version. So where you need to have you need to have some more knowledge on Linux. Okay, so and Jana is good, but it is again more advanced, or it is very good for single crystal than the powder diffraction. Okay, so then when it comes to commercial, you have a lot of other providers like Panadical. They give iScore and iScore Plus. Uh, Even for Brooker, you have some topos and all the things, and like that. Okay, so these are commercial, means you need to pay for that. For even for example, if you take Brooker, for each first license, you need to pay 1,500. This is like you can use it on only one computer. And if you want to use additional computer, then you have to use you have to pay again 500 euros more. Okay, so that is the reason why we would like to go for full proof or Jana or GSAS. So then there is also something called as phase matching. Phase matching is to get basic information from your reported things, like what are the already reported. If you have something reported, then what are the things you can also get some information about the space group and then lattice parameter. So this we do it by using something called as phase matching. So for this, we are going to use Quellex with POWCOD. So you also have something called a COD crystallographic open database. So and also Profix, as I told, this is a new version. So this also will allow you to do the phase matching. Okay. So now in the same way, if you go for commercial, there are commercial like ICDD or ICSD. So then, and also Panadical, Brooker, and all those things, they give commercial database. So a database with some software. So for example, Match is one of the one which is provided by Crystal Impact, and all these things are not free. They need to pay for that. For each single user, you have to pay like 500 to 600 euros for single user. So this is where we are going to use only the open source. There are some disadvantage. There is some advantage. Advantage in the sense we don't have to pay here, but there is sometimes you may not get complete information in the open source. So in that case, you need to go for some alternative. So I will show you how to get information from alternative sources. So as we go on for analysis, okay. Okay, so for full proof, this is your. I think you would have already downloaded it. So this is developed at ILL, as I told, by Roderick Cavazol. So he is the main one of the main guy behind this. So you can get this full proof from their official website. And one good thing is this is updated very regularly. Like almost every year they update it. They remove the bugs which are there, and then they make it bugs free or error free. So and also they keep adding very all new features. For example, like before you need to rely on your diamond or crystal maker have to draw your crystal structures. But now they have introduced Vesta, which can be integrated with the full proof to draw the crystal structure, and it is a free way. So if you want to use diamond, then you need to pay for that. But here, this is what they are doing. So they keep improving, and it is for free. So anyone can use it for for the data analysis. Only thing is, if you are using this free software, please cite it. So this is my personal request. So you have to cite their paper. So this is one of the paper, 1993. So this paper explains the full proof suite. So if you are using this software, please cite these papers. This is also already there in the website also. So they give this. You please cite this. So that is the only thing I can ask. So and also we can give that. So we don't have to pay any money for that. Okay. So next.
This is your Jana. This is very good in terms of single crystal data. So if you even if you want to do direct space mapping, so then you can do this in this Jana. So apart from X-ray diffraction, you can also do neutron diffraction uh, uh, refinement, both in Jana and also in foolproof. So this foolproof is developed such a way that you can do refinement for X-ray diffraction, synchrotron diffraction, and also neutron diffraction. All the things you can do in the same thing. Same thing with Jana. You can do X-ray, synchrotron, and neutron diffraction data refinement on using this software. Okay. So with this, I think I will stop here right now, and then I will try to explain you some basic things for your full process. Okay. So if you have already downloaded the foolproof software, you'd get some logo like this, foolproof suite 64-bit. Okay, if you open this foolproof, you'll get this bar kind of structure. So here you can see there are a lot of icons. So each icon is individual program. So if I click this, it says run wind plotter. So if I click this, it will open a wind plotter new window. So this is 2019 version. So this is a new version of wind plotter. In the same way, if I try to click the other one, green one, then it will also open one more window. So this is wind plotter 2006. So this both are wind plotter, but only the version is different. Okay. So this is called as wind plotter 2006. This is called as wind plotter. So most of our in our case we are going to use wind plotter new version, which is your April 2019 or anything recent one. So what is the use of this wind plotter 2006? It has some different features. So I will show you those things one by one. So what is the use of this wind plotter is, it is having 2-3 different functions. The first one is you can open your X-ray diffraction data to see how your data looks like. Okay. So for that you have to just go here, click on this open button, and then you can select your what kind of data you are having. Okay. So I will explain this one again later. Then you can also run your foolproof program or your ritual program from here. Okay, so if you can click here, this button will help you to just run the foolproof program. Okay, so then you also have something called as EDPCR. Okay, so EDPCR is edit PCR. So PCR is a programmable crystallographic reader. So this I will again explain later. So the same icon is here, EDPCR, okay, on your foolproof suite. The same thing, these two are the same. If I click this, I get a EDPCR window. So something it looks like this. Even if I click this, I get the same window. So both are same. You can launch either from here or from here. Okay, so these two are your EDPCR. So I will explain why you need that later. Then you also have something called as FP Studio. So this is your foolproof studio. So if I click this, it will again open a new window which will give the some something like this. So if I click here, I can open the crystal structure of some compound. Okay, so this is just an example. So I'm not I will explain again in detail. Okay, so you can see here this can be used to visualize your crystal structure. So this is one of the visualizing one, but this is good for having to visualize your magnetic structures. But for having better, you have one more version which is called as the Vesta. Okay, so if you go here, this icon is as Vesta. So if I click this, it will open. If it is linked, then it is going to open a Vesta program. Okay. So if not, you need to download the Vesta. and then you need to try to so you need to try to link it. Okay, so I will show you how to do that. Okay, so I think in my case I don't have Vista right now, so so what I will do is I will search for Vista. So maybe you have already downloaded this version. So this is jpminerals.org. If you go here, you can have the package for Vista. So for me, I am using Windows software, so I'm going to download Vista with 64-bit. So how to know whether it is 64-bit? You have to just go to your computer, my computer, or your main computer. Okay. So or even if you just open your, I will try to show you. Okay. So if I go here, my computer, if I do right click, and if I go for properties, then it will give the information about my system. So I'm using Windows 10 with 64-bit operating system. So sometimes you may be having 32-bit operating system. So in that case, you have to try to download your softwares, whether it is foolproof or any softwares. You need to download only the 32-bit. Okay, so uh, if you go here, if I see here, you have both. This is for 32-bit operating system, but for me, I'm using 64-bit. I'm going to download this. Okay, so this is not big file, 17.1 MB. So it is smaller one. So here, when it comes to Vesta, you don't have to install the Vesta. What you need to do is you have to just open that Vesta, whatever is the one which you have downloaded. Okay, just so you open this Vesta RAR file, and then you will see there is a folder with Vesta. Okay, so what you do is just you copy this entire folder into one of your into your computer. Okay, so what I will do is I'm going to just copy it to my just okay. So I think I will explain other things. Till then, you can. Okay. So I'm just going to copy this to my desktop. So I'll just extract it to desktop. Then so it is sitting in my on my desktop. So what now I will do is I will go to this foolproof suite, and if you go to settings, there is something called as external program Vesta. So you click here for this browse. Okay, so then you have to go to this folder. Okay, so you click settings, and then click on Vesta browse, and then you go to the desktop. So this is the desktop. So then what I do is I will look for Vesta. So this Vesta 64. Then what I will do is you should see something called as application. Okay, so Vesta application with this symbol, you just open this and then you tell okay. Okay, so you just have to give that link. Okay, so the for vesta.exe. So you go to this, select it open, and then you say okay. So now if I click on this, it will run the Vesta. Okay, so normally it will take some time, but it will run. Okay. So first one was your FP Studio. Second one is your Vesta. So this is your Vesta. So I'm going to show this in the next sessions, maybe in the third day and fourth day. So I'm just showing what are the differences between these things, between your foolproof and Vesta. Okay. So that is why I'm doing it slightly quickly. So I'm not spending too much time. You need to just look for some zip file. So you can see this is the uh, this is the software for this is a crystal structure from Vesta, and then this is how it looks for with your foolproof studio. Okay, foolproof studio is normally mostly used for having this kind of magnetic structure. So this is a magnetic structure with antiferromagnetic arrangements. So this is for general. So you can show your crystal structure using Vesta. Okay. So this again will come back in detail. So we'll do it in detail. So in the later stage. So these are the different programs. You also have something called as Fourier G Fourier. G Fourier is to have the Fourier transform of this of your sample. So all these things we are going to do one by one. So for now, what I will do is I will just concentrate on this two things. One is your wind plotter 2006 and wind plotter. Okay. So you can do this exercise or you can try to get familiar with this wind plotter. So that is the reason I'm just going to show. Okay. So let us use the new version, which is your uh, Windows 2019. So then what you do is you can click here. Okay, if you click here, then what happens? It will ask what kind of data you want to import. So normally you can use either your X, Y data or free data. Okay, or you can also go for some other like fanatical data. Fanatical is if you are using your fanatical machine, you can directly take .xrdml and then you can import here. But most of the times what happens, you may be using Bruta or Rigaku. So what I suggest is, for simplicity, if you are starting or if you are a beginner, always try to use XY data. Okay? So for this, I asked you to download what we call as a Powdle, POWDLL program. So this program can be used. So I will show you that. So if you have installed that Powdle, then you will get this Powdle converter, something like this with X-ray symbol, blue color. So if you open this Powdle, then you can use this Powdle to convert your data into XY format. Okay. So I would suggest you to just convert your data to XY. So for simplicity, later once you get used to this refinement, you can use directly raw data. There's no problem in that. But one more thing, what I wanted to share is, don't try to change your raw data. If you're changing your raw data, like if you're trying to, for example, if I go back. So if I go back here, then for instance, you're giving your sample to your X-ray operator. So he is going to send you the data, which would look something like your uh, red line. Okay. So what you will do is you don't have too much time to do one more scan. So what you do, you ask your X-ray operator, or you may ask your friend to do smoothing of this curve, the red curve, to just get something like blue because you want to reduce the noise. So in that case, what happens? If you're trying to do smoothing of the curve manually by using a software, or either you do it on your X-ray machine or you do it on a origin, what happens is you may lose some intensities or you may lose some peaks when you're trying to do the uh, so when you're trying to do some smoothing, okay, or you may induce some extra peaks. So for example, if there is some hump here, if you try to smoothen this, then what happens? You may get extra peak, which is not exactly from your sample, but it would be due to data manipulation. Okay, so don't do that such kind of things. You take the raw data and always try to do analysis on the raw data. Don't try to do the smoothing or removing of the background. So for example, even if I take this blue curve and if I try to remove the background, then what happens? There will be a one more extra peak which may be induced due to some intensity, okay, leftover intensity. So always don't try to take any or don't try to do any kind of uh, data treatment, okay, for your sample. So what you can do, you just take the data from the machine and then do the analysis, okay. So once you have your data, you ask your X-ray operator to send the raw file, whether it is from any format, doesn't matter. Okay? Then you can convert that raw file into XY by using this Powdell converter. Okay. So I will show you just one example. For example, if I have some data like so for if you want to see some examples, you can directly go to C program. So your C drive. So if you go to C drive, there is something called as foolproof suite. Okay. So in this foolproof suite, you will have something called as examples. Okay. C and then foolproof, and then inside foolproof you have something called as example. If you go into this, then you will have a lot of examples. So maybe here they already have given in XY format. So you can see there is already these things are in the XY format. So what I will do is I will go to some other folder where I can get the some other form. Okay. Okay. So normally you can convert your files. For example, you can see here these are different files that you can open here and you can convert. Okay, so if you click here, it will ask your raw data. You can take your raw data, whatever raw data you have, and then you can try to convert it. Okay, so right now I may not have proper one. I will show you again next time. So you can use any of this data. You can take data from your Bruker machine, or Rigaku machine, or any machine. Okay, syntax, there is a syntax, and then these are old canonical. So even you have some other formats like canonical XIDML. So this is what you normally get from a XID machine. So you can take this data, you select the data, and then you convert it into .xy. So if you just select the XY format and then you just click convert, then it will convert into XY format. Then you can use that data as the starting point. Okay. So this is what we normally do. I will just show how to do that. So if I take this XY format, then what I do, I can browse my data wherever is my data. Okay. So then I can try to okay, so I will try to do this. So this is my XY data, but what I have done is I have just put that as dot dat instead of dot xy. I have put it as dot dat. Okay, so if I click that, then what happens? It will open the data like this. Okay, so this is for visualization. So you can do this exercise yourself. Okay, you can open any data. So for example, what I will do is I am going to I will open the data which is already in the computer. Okay, so which is coming with the full proof. So I will go to C drive, I will go to full proof suite, I will go to examples. Okay, then I will just click CO2. This is your cerium oxide. So okay, so this is giving something like this. The reason is I will tell you why. Okay, so if I go open this CO2, you can open it in using a notepad. So if I open this using a notepad, so you can see here this data looks like this. Okay, so this is something like 25, then 0.025, and then 145. Okay, 143. So what is the meaning of this is this is your starting angle, this is your step size, then this is the end angle. So if you go here in the data file, I took the first one. Instead of first one, if I take the second one, you can see here it is TI. TI is the initial theta. Initial theta is 25. Then step is 0.025. They have used 0.025 step. And then TF. TF is the theta final. So if I use this now, and if I try to open the same data, then I think I need to reset this. I'm going to check this, and then I'm going to open this. Then what happens, you can see I can get the in the proper one. Okay, so this is your intensity in the y-axis and 2T in the x-axis. Okay, so you need to check what is the exact thing. So if let me see if I have some xy format. If I have some xy format, then it should be able to open it. Okay, so xy, then I will try to open. No, this is not same thing. Okay, so if it is x comma y, then what happens? You will have x in x-axis. You have your this thing. So I will take this example. So if I take this example, so in this case, what happens? If it is XY format, then you have two columns. The first column is for theta, the second column is for intensity. So now if I open this using your XY, then it will open in XY form. Okay. So this is one thing that you need to check what is the format of the data before importing the data. So now what are the things that you can do from here is you can stack more number of data. So for example, if I want to see more than one sample or one data, then I can again go here, click XY, then I will take the next one, maybe this one. Okay. Then if I want to do again one more, I can do this. I can put one more. So this is mainly used to do the visualization of your data. Okay, so WinPlotter is one of the uses visualization of the data. So you can see here I have three different samples or three different profiles which can be put in one, and you can also do some stacking, like you can make it shift your y-axis or x-axis, something like that. Okay, so this is one of the use. The next use is you can do some background selection, all those things. Okay, so these things we are going to use again very commonly we are going to use. So that is why I'm spending some time here. So if I want to take the background of this, what I can do is I have to go to point selection. Then I have to go to either I can do automatic background or I can do manual selection. Okay. So if I go to automatic background, then it will ask what are the some by default values. So if it is noise data, that means if it has too much of scattering, then you can click here noise. If not, in my case it is fine, so I will do. So in this case, what happens is it will automatically take the background. Okay. So then you can save this background. So you go here back again, then you can save the background. You can give a name for that background. Okay. So I'll give a background, something like that. and then comma xy or whatever it is, then it will save the background. Okay, so this then you can see you can have all these background points in here. There is one more way is you can also do it in the using your manual one. Okay, so I will reset this. So then I will show how to do manual background. So you select your xy comma your data in xy form. So for example, I'm taking this. Then if I want to do a manual selection, first thing is you can zoom it. If I want to zoom it, what I do is I click some portion, right click, then you have to leave it. Okay, so you have to click it and drag it. If I leave it, then it won't show. Okay, so you have to just select and drag it. Now you can see it is this is your zoom part. Go to select background point, and then you go to you can click the background points. Okay, something like this. So you can select your own background points. So when you are doing this background selection, you should not take anything in between the picks. So don't click here, this is not a good selection. Okay, always try to take the background points in between the picks. So sorry, in between two picks, so something like this is flat region. Okay, don't try to take in the in between any in the middle of the peak. Okay, so you should always take like this. You can select your own background. So if you want to move, you can use this arrow mark, and then you can select it. Okay, so now if I want to save the same thing, save background, yes, I want to save, then I will give back one, something like that. Okay, so it will say, okay, you have selected 17 background points. Fine. If you want to see that, yes, I want to see, then it will open. Okay, so all the 17 points it has put here. Okay, so this is how you can do the background selection. So there is one more thing what we are going to do is we are going to learn this kind of this all these things like default tray or ITO. So these are what we call as indexing programs. So this also will be used by using your win plotter. Okay, we are going to work on win plotter. So next and also we are going to work on the on your EDPCR. Okay, so EDPCR I think I will start tomorrow again. So now one more thing is, what is the use of this old version? This old version is good for having stacking. Okay, so for example, I want to open this. So I'll open this same file. So I'm going to send you to this some of these data files for doing tutorials. So if I go to TiO2, and if I want to take this one, then this is in XY format. I'm going to say take this is XY. Okay, I have plotted here. Now, so this is first one. Next, if I want to again do one more plotting, what I do is I'll say take this. I'll take the second one. Okay, so and then this is your XY format. Select it. Okay, so sorry for that. Okay, so this is your second one. Then I'm going to take the third one, maybe something like this. So this is XY format. Fine. Then maybe fourth one. So if I do all these things, so you can see it is stacking here. So you can see the stacking like this. It is a 2D view. If you want to see a 3D view, you can see here there is something like it is giving open 3D model. So if I click this, okay, I think if they are having the same phase, same XY, sorry, X coordinates, like if your step size in the same, then what happens? You can also see 3D views. Okay, so in this case it is not taking, so it's fine. I'll try to take some other example. So I will take some of the example where we can have same X formats. X in the sense step size has to be same. If you are having different steps, then this won't work. So that is the reason you need to have same its format. Okay. And you should have at least uh, 3 to 4 uh, data points or data. If not, it won't work. Okay, so then so now I have this. I think okay. So I will show you this again one of some other time. Maybe I think. Okay, I think I'll take this. So I will keep stacking maybe 3 or 4 data points or different datas. So I have stacked 4. Now if I click here, somewhat is not working. Okay. So I think I will show it again some more time. So the one use is you can have it in 3D data. 3D data in the sense 3D form. So if you have any kind of transitions, it is easy to see how this transition is occurring. Okay. So this can also be used to give it in your publications. So you can show 3D maps in your publication. So for that, we are going to use this old one. That version is not available in the new one. So that is why they are keeping still this older one. So I will show that example some other time. So now these are the users. So you can actually do data viewing, and also you can also do some data treatment. Like if you want to select the background, all those things you can do. So what I would suggest is you try to uh, open the data which are already there in your C drive. For example, in case of your if you go to C drive, then if you go to full proof, then you have examples here. So you try to open them one by one. So if it is giving some error, that means this is not the right format. Okay, that means I have not taken the proper format. So then you have to check what is the proper format. So if it is proper format, then it will give like this. You can open the data, and then you can try to play with this data. Okay, so try to get familiar with your wind plotter and those things, because later you are going to use this. Okay. So this is one thing you can do. So then what we will do is I will also show some example with Quillex. Okay. So now for now I'm going to close this. So this is we will come back again with each one of them, how to use EDPCR. So EDPCR is normally used to open your PCR files. So this again will come when we do the profile matching and profile fitting. So you can create your own PCR file, or you can also you can open the existing file and do some modification. Okay, so that is the reason why you need this EDPCR. And then I have shown the use of Vesta and also the use of full proof suite. So now let me stop at this point for full proof, and then I will show the Quillex. Okay, so Quillex is used to do the profile phase matching or profile matching. So if you open this Quillex, okay, so you will get this this window, again I'm going to do again more phase matching tomorrow. So at that time we will go in detail. For now, I think I'll just show the uses. Okay, so uh, once you have done this installation, normally what happens, you go to search and then you go to database indexing. Okay, so in database indexing, so if you are doing for the first time, so you would have nothing here. It will be something like this, empty. So what you are supposed to do is you have to link a uh, the database. Okay, so database is nothing but it is the one which is having all the reported experimental files. Okay, so for this you have to click here new, and then sorry, search, go to search database indexing, click on new, then you would have downloaded POW COD. So you have to go, you have to extract that POW COD to one of your uh, local folder, then try to look for that. Okay, so POW COD, then you can okay, just okay. So I think I lost it somewhere. So it's fine. I will. Okay. So from beginning, I will show you. So you go for your database. So you can go to Collects database, your website, and then what you do is you have to log in before you can actually download. Okay. So uh, I think yes, here I can log in. You can create it for free. It's not a paid version. You have to just register, and then you log in with your credentials. So you would have already downloaded this Quellex 2, and also you would have downloaded the POD. Okay, so if you go Quellex, so here somewhere, you go to Quellex, then you will get POD. Okay, so POW COD, which is your crystallographic open database. Okay, so I will just try to download one of them. So I will just go to download this, and then you need to extract this. Okay, so once you get extract that, then you link it with your data, your Quellex. Okay, so what are the uses of this Quellex is you can import your data similar to what you did in case of your WinPaper. So here it is asking what kind of radiation you have used. So I will say, okay, this is my copper radiation. That means I'm using copper X-ray tube to generate my X-rays. So then you can see these are the diffraction pattern. Okay. So this button will help you to unzoom everything, and then you can zoom by the same method. So whatever you did in WinPlotter, you use the same methods for zooming. So if I want to zoom this, I can do this. And as I was telling, if I am using copper alpha 1 and alpha 2, at higher angles, you can see each peak will have two peaks. But this corresponds to single reflection, your HKL reflection. One is from K alpha 1, K alpha, the second one is for K alpha 2. Normally, this intensity will be equal to 1 by 2. Okay, so if this is 100, then this will be 50, something like that. Okay, so but as you go to the lower angle, the gap between two peaks will be very less. Okay, then when you go to even lower angles, like anything less than 30, you won't see the two peaks. Instead, this looks like some shoulder. Okay, but actually this peak is from K alpha 1, this shoulder is from K alpha 2. Okay, so these things you need to remember when you do the next steps. Okay, so at higher angle you can see this gap is becoming better, okay, or it is becoming more. So now I think I will take some questions, then I will by the time it finish downloading, then I will show it again. Okay, so I don't know where we stop. Okay, we can identify the, okay, then as far as I know, there are two types of diffractometers, Bragg-Brentano and Debye-Scherrer. How to distinguish those type of diffractometers, and then how will it affect our analysis? So it won't affect your analysis. One thing, how to distinguish is if this the one I showed you before is your the old diffractometer is your Debye-Scherrer diffractometer. So the one with where you keep your sample in the middle, and then you have the. So let me come back. I think. Okay, so this is your Debye-Scherrer camera or Debye-Scherrer diffractometer. So you have a sample here in the middle, then you get scattering. So this is your Debye-Scherrer diffractometer, and the one which normally you are using in the modern time, the one which is like this. This is your Bragg-Brentano. So it is just the geometry of your X-ray diffractometer. It doesn't matter. It doesn't affect your analysis as long as you have good intensity data. So if you have good data, then you don't have to worry about the analysis. So previously I used GSAS, but I need to decide which diffractometer type, but I am not sure about it. Does full proof need such information as well? Could you please explain about? Yes. So this is what I was telling. So if you don't know what kind of data it is, best thing is use your PO, your Powdell converter. So the one which I showed you in this case. So you convert it into XY format. That is a simple form where you can use it for any analysis. Okay, even it will work on Quellex, it will work on your GSAS, it will work on Jana. Okay, so one thing what you can do is you can always select your data file, whatever it is. It may be .ras, it may be .xrdml, it may be .raw. So you open it using this software, and then you convert it into XY format. Okay, so then it will be easy for you to use in your this one. Okay, in any analysis. Is it possible to do refinement if the data density is low? Yes, you can do the refinement, but what happens is there is something called as RWP, which you will again learn. So that would not be that will not decrease. Okay, so that depends on the quality of data. So there are different parameters that you are going to learn. That is your validating parameters. So this parameter will not come down, like your chi-square won't come down if your data is not good. So you can still do for low intensity data retool refinement, because some samples will not give good diffraction. If it is hygroscopic or something like that, or even some organic samples, they won't give very good diffraction. So in that case, what you can do is you can still do the refinement. So that is fine, you can do that. Okay, So I am interested to learn flip. So this is the main purpose of the workshop. So we will maybe at the end of fourth day, you would be learning this. Okay. So this you don't have to remove the background. So what we are trying to do there, we are going to again do that. Okay. So we are going to do profile fitting, and also we are going to do ritual fitting. So during that time again I'm going to show how to collect how to select this background points. Okay, so it will be like repeated, so 2 times 3 times you are going to see. So you will learn that. One thing is, don't remove the background, because there is no need to remove the background. If you are not removing properly, then as I told, you may induce some peaks, or you may delete some peaks. Okay, so that is the reason, don't try to remove the background, instead try to select the background. Okay, so again, background correction what I showed is by using manual background. There is, you can also do the same thing for uh, using a polynomial. So you can ask the full proof to fit a polynomial. So that also we are going to learn. So those things we will again learn. Okay, so this is the first day, so don't worry too much. We will come back to this. Then okay, so then for phase identification in XRD, it is enough. Is it enough for angle to match, or should we also go for intensity matching? How important is this? Okay, so this we have one session dedicated for phase matching, phase identification. Okay, so we are going to do this. So if you see our sessions, one session is purely for phase identification. So there I will again explain all these things. So don't worry. So today, right now, it is just introduction. This is just start. Okay, so we are going to do it step by step. Slowly we are going to do it. We are not, I am not going to go it in a hurry. Okay, so we'll do slowly each things: profile matching, full proof, your ritual refinement, and phase identification. So we will do, each session will be dedicated for this kind of analysis. Okay, yes, I will share the PowerPoint. I will share all the recordings, even the recording what we are having, we are going to share it. So don't worry. So I will share everything. So it's not, nothing is confidential. Okay, so this, even we are using all open source, so I don't have any problem in sharing. So I will share the videos, I will share the PowerPoints that we are using. So it will be useful later when you have some doubt. Okay, so I think by now it has completed. So I will open this COD 2007. So now the same thing here. Now what you are supposed to do is, I think I'll put it in my on my desktop. So okay, take some time, let it complete. Okay, so now what I do is, I'll create a new folder here. So I'll call it as COD. You can call any name, doesn't matter. Then what I do is, I have to extract all these 4 files into this folder. Okay, uh, I can do it just by dragging them. So I select everything, I drag it here. So it will extract all the things. It will take some time. So once you download that, you just do the same thing. So you don't have to install this. You have to just put it in a folder somewhere which is convenient for you. I'm putting it in desktop. You can even put it in C drive or D drive, E drive, whatever drive you want. But you should know where you have actually put it. Okay. So if not, then it will be difficult to identify. So same thing happened for me today. I was trying to search where is my POD folder. Okay, so once what this contains is, it contains all the database in one file. Okay, so now I will go back to this get QLX, then go to search, and then go to database indexing. So initially it will be empty like this. Then you click on new. Then it will ask where is your .sq file, POWCOD file. So now what I do is I'll go to desktop. I'll go to that folder POWCOD. Then you can see there is a SQ file. I'm going to open this SQ file. So now what it's showing is, it is showing that it is not selected. Even though it is coming and sitting here, it is showing it is not selected. So what I do, click on this, and then I say select POD. So it will change to yes. Okay. So I'll repeat again. So I'll delete this. I'll go to new. I will select this, open it. So right now it is showing, okay, it is not selected. So you can click anywhere here. So now I'll say select it. Once I say select, then it's showing yes, it is there. Okay. So now you close it. Then it is ready to do the phase identification. Okay. So this phase identification again we'll do in detail tomorrow. Okay. So now if you have any doubt, you can ask me. If not, what you do is I would suggest you to open your foolproof suite. If you are not installed, please install your foolproof suite. Install your Quellex. Install your Vesta. So Vesta you don't have to install, just copy it to some folder. Then same thing, copy your POWCOD to one of the folder. Okay, and keep it ready. So next, when we come tomorrow, we will again go back and do the phase identification. Okay. So if you have any doubt, you can ask me. If not, we can close today. So someone asked for feedback form. So feedback form I will give it in the end of the workshop, because for your attendance we already gave your attendance in our WebEx software, so we know who is attending. And if you have any feedback, you can always try to write to me. So you send the email if you want to if you have any clarification, you can write email to me. And if you have any questions, you can ask. If you have, I think, let me go back again one more time. Do you have?
Hello.
Yes.
Hello, sir. Myself, Purita. I'm doing research on the nanomaterials.
Okay, madam.
Sir, actually, I want to know this software. No, for this software, we have to take the raw data or ASCII file data.
See, what I would suggest is take your raw data. And
Raw data means that graph you are telling.
No, file. If you
Actually, okay.
XRD, so you are sending your sample to someone to take the data.
Okay.
Sometimes, most of the times, that is what happens. You send your sample to someone, they are going to do the X-ray diffraction.
Yeah.
So what you do is you ask him to send the raw data, not the ASCII data. Okay.
Actually, sir, whatever we received the data from the XRD characterization, no? So they will send the ASCII file, not the raw data.
You can ask, they will send.
Okay.
See, sometimes what happens when they are sending ASCII file, they may do some smoothing of the data, or something like background correction. So in that case, they would have already manipulated the data. So that you don't want, because each peak and each intensity is important for doing the analysis. So whatever we are going to learn, so you will see like each peak position, peak intensity is important. So for
Sir,
better to take the raw data.
Sir, it is not possible from the ASCII data.
You can do it. There's no problem until unless it is if it is in XY format or anything. If it is in XY format, you can directly open it using your WinPlotter or anything.
Okay.
So you can also use ASCII file. When we are converting into XY using your Podal converter, it is actually giving you the ASCII file.
Yeah.
It is taking your raw data and it is giving the ASCII file. So even you can start with the ASCII file, no problem.
Okay.
So it is fine. We will do it. No problem.
Sir, will you teach that how to do by ASCII file and raw data?
Yes, yes, yes. I will do it.
Okay. Okay. Okay, sir. Okay. Okay, sir. Thank you.
Okay. So do we have to have a WinPlotter software too? No. See, once you have installed the foolproof suite, it has already. It will come with WinPlotter. WinPlotter both WinPlotter recent version and also WinPlotter old version. You have to just open this foolproof suite and then you will get both. It is already installed. You don't have to install separately. So only thing is Vesta you have to just you have to download and keep a folder. You have to keep you have to give a link for that, and then when it comes to Quellex for POWCOD, you have to extract the files. Only these two things are separate. Other than that, everything is coming inbuilt. Even if foolproof studio is inbuilt, EDPCR is inbuilt. So once you install your foolproof suite, everything is already present in this in your system. You don't have to separately install your WinPlotter. So okay, I will share some files in the afternoon so that you can do some analysis. You can already take the data which is already present in your data, sorry, in your computer. So once you install the foolproof, your full installation will create a folder called as foolproof in your C drive. Okay, foolproof suite. And if you go there in the examples, you will have a lot of examples. Okay, so you can use these examples to play with or to start with. If not, it's fine. I will send you the data that will be necessary for doing the your next practice. Okay, and even for next things, I will send you the data. Or you can use your own XRD files. Whatever you get from your samples, you can open those files using WinPlotter and try to select your background and all those things. So if you don't have any questions, I think we will stop at this point. And again, we will start tomorrow at 9:30. So there is no inauguration or anything. We'll directly start with whatever is there. So I think we'll start with phase matching. So try to join before 9:30, maybe around 9:15, 9:20. Try to join by that. At 9:30, we will start it. So we won't wait for everyone. So please try to be on time, because if not, we cannot cover all the things, because we have a lot of things to cover. So please be on time. We won't wait because there is no other official sessions. We will just start the session and we'll go with the analysis. So if you don't have any question, then we will stop at this point, and we will start tomorrow at 9:30, sharp at 9:30. Okay. So thank you one and all. So we'll see you tomorrow. You can leave if you don't have any question.